Good morning, everyone. My name is Casey Morris, and I'm here today from the National Institute of Standards and Technology to talk to you about the sustainability context for manufacturers in the U.S. I've been a group leader at NIST for many years, working in the digitization of manufacturing, and most recently looking at how that can be applied for sustainable manufacturing. NIST is the U.S. government agency whose mission is to promote U.S. innovation and industrial competitiveness by advancing measurement science in ways that enhance the economic security and improve our quality of life. Measurement science means that we study the way things work to develop consensus on how things are specified, measured, and tested. In other words, what to measure, how to measure it, and how to communicate to others what we've learned through those measurements. And I'm talking about all kinds of things, like you see here, physical measurements, time, cybersecurity, and sustainability related topics like how housing and construction uses energy or manufacturing systems, which is where I have spent my career. So a little bit more about NIST. We consist of research laboratories. There are 6 of those. I'm in the engineering laboratory, and we look at engineered systems and products. So I'm going to tell you a little bit about the sustainability journey for U.S. manufacturing. First, I'm going to talk about sustainable manufacturing in a circular economy, and then we'll get into a little bit more about smart manufacturing and standards that will help deploy these new technologies. So today's problems are global, plastics being a case in point. Plastics are showing up on the shores of many countries that did not produce those plastics, and in the waterways globally, we're finding microplastics. These problems need science-based solutions from material scientists and social scientists and manufacturing scientists. Manufacturing will definitely be a big part of these solutions, but plastic is not alone. There's the carbon problem of global warming, there's high-tech waste, there's clean energy technologies, food, textiles, cement, steel, many, many things coming down the pipe that we're going to have to learn how to manage better. As populations grow and our resources are becoming more and more constrained, and our ability to manage the waste of those resources is a big problem. So what is circular economy? Circular economy is a response to all that. We're looking at a new economic model where all materials can be kept in the economy at the end of life. As products are used up, they're either reused or brought back in through recycling or other means, rather than going to the landfill or into the atmosphere in ways that would be less desirable. So who cares about the circular economy and sustainable manufacturing? Well, pretty much everyone these days hopefully knows a little bit about it. Future generations need us to do this now so that the world will be a nice place as they grow and change. And governments worldwide are starting to talk about this and negotiate treaties to help make sure that everyone is doing their share in producing a more sustainable world. Industry, investors, consumers are all very aware of what's going on and trying to respond to it. The chart you see on the right there is a chart of the large multinational corporations that are producing sustainability reports annually. And I show you this to show you how much of an increase there's been over the last 20 years in the attention that's being given to this topic. And these are the large multinational corporations, like I said, but what about the small and medium manufacturers? Well, my group looked at that issue very specifically. We looked at data that had been collected over the last couple decades from our Department of Energy and through NIST with our manufacturing extension partnership that reaches out to small and medium manufacturers. And we found that there were barriers that had been preventing them from addressing sustainability projects more aggressively. We identified 3 groups of barriers, what we call strategic alignment. This is the difference between what a manufacturing organization's goals are and what the needs for sustainability are, and those being misaligned. Financial outlook, where there's the idea that if they invest in sustainability projects, it could undermine their own bottom line. And then there's organizational feasibility, just knowing how to do things. And we found some of these barriers are beginning to be addressed. The strategic alignment we actually saw when manufacturers were implementing projects that were based on standards that allowed them to be more efficient in their operations, that they were retaining customers and increasing their sales. A lot of that is being motivated by a drive to from their supply chains to make sure that the small and medium manufacturers are using best practices. As far as the financial outlook goes, we saw that over time, there was evidence that there was actually good payback on many of the projects that could be done to improve the efficiency and reduce the amount of energy specifically that was being used in manufacturing facilities. And then the organizational feasibility. This goes to the know-how of an organization to address these types of projects and problems. And what we're seeing is that by basing their new projects on standards, they're able to help to address some of those feasibility issues. And we hope to see more of that in the future as more sustainable related and circular economy related standards come online. So in short, the benefits for manufacturers are multifold. You see social benefits where their brand improvement is allowing them to address their customers' concerns more ably. Employee engagement, we're hearing from manufacturers, is going up when they know that the organization is addressing sustainability concerns, and investor relations are also a big part of those motivations. Then beyond that, there's the improvements in operational efficiency, and then the benefits that can be derived through collective action. In other words, working with other organizations within their industry that are trying to address similar concerns gives manufacturers a way to get a head start on some of the problems that will be facing them down the line. So where's smart manufacturing come in to all this? Circular economy, as I said, it needs new manufacturing practices across the entire life cycle. So sustainable manufacturing in the past has been very focused on things such as zero waste operations and improving operational efficiency. We've seen a lot of opportunities there and a lot of improvements there. But with circular economy, we want to look at that even larger life cycle from product design and smart materials management and measuring and managing the system dynamics and the different players within that system. So here I'm showing you on the right here is the zero waste hierarchy. There's several versions of this. This is one, but what they all seem to have in common is that the bottom of that hierarchy is this mismanaged disposal, which of course is what we're all trying to avoid. We don't want oceans full of plastic bottles. And then just above that is managed landfilling. But there's many more beneficial ways to look at the use of the products and the materials at their end of their use. And so redesign is probably the most successful way to reduce impacts across the whole life cycle and to make sure that the materials that the products are made of can be used, can be reused as the product reaches its end of use. So these are just some ideas of how smart manufacturing might apply to these areas. Impacts of measures available to the designers will very much help inform them what their options should be as they redesign products. Process quality and efficiency is definitely going to help in the reduction of discarded resources. Reuse, remanufacturing is a great option there. And then when you get to recycling, there's automated sorting and scheduling and more advanced recycling techniques such as chemical processing and so on. Ultimately, though, we need to create this system in such a way that we can look at life cycle optimization across not only a single product line, but a whole community and beyond. So there's going to be a lot of challenges as we go forward there, but lots of opportunities to apply these new technologies to help address those challenges. So the sustainability journey wraps up here with standards for sustainable manufacturing. To address the needs of future, standards are needed at numerous levels, and I like to use this Venn diagram to describe the difference between these different types of standards. This is a Venn diagram because the areas are definitely very much overlapping, but these are somewhat distinct approaches to addressing the circularity and sustainability challenges. So in the goals bucket, the UN is obviously very influential in this regard, but there's other organizations that are as well. The greenhouse gas protocols define specific metrics for companies to respond to reduce their emissions. And many organizations are using those now, but then there's also groups like the Sustainability Standards Accounting Board that have been instrumental in laying out priority areas across 77 different industry sectors. So each organization is going to have different goals and needs for their own journey, and these 77 different industry sectors can help guide manufacturers as they embark on this journey. The blue box represents efforts that provide best practices for managing towards these goals. These standards address a number of areas that improve overall efficiency of the manufacturing operations, and when followed can help strengthen the manufacturer's corporate culture and readiness to pursue new sustainability objectives. It gives them the discipline built into their manufacturing processes to embark on these new projects. And then the tan box labeled measurement includes both physical measurements, but also the technical standards that are going to enable the automation that define the product designs, the material characteristics, and these things will drive our capabilities to extend their use in the economy. At each life cycle stage, there's not only opportunity for significant activity to improve on capabilities, from advanced analysis to produce better, higher quality, longer lasting, less impactful products and materials, to practices to enable products and materials to be reclaimed at the end of their life rather than turned into waste. Advances run the gamut, and the measurement areas, this measurement area is the largest category of standards because each situation will be unique, and each situation will have to pull together the range of standards that will be needed for their own organization. These standards must be very precise and responsive to variability in materials that are coming down the pike, and more agile for the changing conditions, such as the wave of supply chain disruptions that we've seen. You can see in this figure here, these standards cover multiple life cycles that engage manufacturing. There's the product development life cycle, production life cycle, and the business or supply chain life cycles. All of these offer opportunities and for sharing information downstream within their own life cycle. But as you can see with Industry 4.0 and the new digital manufacturing, more and more opportunities are arising to share information across different life cycles and directly into or from the manufacturing production systems themselves. Thank you for your attention today, and I wish you the best time at the conference. I wish I could be there. Thanks. Bye.